Again, by using digit 1, 2, 3, 5 only, we have to make 5-digit number without repetition, such that the 100th place digit is always greater than unit place digit. Correct? So if I take 5-digit number, then definitely this is the 100th place digit and this is the unit place digit. So if h is the digit at the 100th place and u is the digit at unit place, then as per the question, u should be greater than h should be greater than u. Now how do I ensure that? So there are two approaches. Again, one would be a very methodical method wherein we'll make all cases, and I like that method as well, right? Because it helped me a lot to understand the question in depth, and the method also helped me a lot in logical reasoning questions. We have to make a lot of cases, so one should not be deterred in using the case method of solving the question, right? So what I'll do is that out of these 5, let me find out the pairs which I can put it at these 2 places. So I come across that if I take 5 here, then at the unit place I can take 1 or 2 or 3 or 4. So 5, 1, 5, 2, 5, 3 and 5, 4. So I can say there are 4 pairs, 5, 1, 5, 2, 5, 3, 5, 4. If I keep 4 here, then we can use only these 3 cases. So there are 3 more pairs. If I take 3, then we have 2 cases. If I take 2, then we have only 1 case. So the number of cases, if I add them, this is nothing but 10. So I can say if I take the task at 100 place and task as unit place, and if I combine them, so combinedly these 2 tasks can be done in 10 ways. And every time we will be using 2 digits. So out of these 5, we are left with now 3 digits. So for this place, we have 3 options. So again, for this place, we'll have 1 option, and for this place, we'll have 2 options here. And for this place, we'll have 1 option. So definitely the answer would be 3 into 2 into 1 into 10, which comes out to be 60. So 60 is the answer for question number 7. Now let me take a different approach here. So rather than making cases, I can do it straight away also, without the restriction that 100 place is greater than unit place. If I make 5-digit number using these digits without repetition, then those numbers will be 5 into 4 into 3 into 2 into 1, right? Which is 120. Now for this case, I can say there will be half the cases wherein 100 place digit will be greater than unit place, and half the cases where unit place will be greater than 100 place. Why so? Because if all the number where 5 is at the 100 place and 1 is at unit place, we'll have same number of numbers wherein 1 is at the 100 place and 5 is at the unit place, right? You remember that every number can, or every digit can come at every place equal number of times. So the number of numbers where 5 and 1 are fixed respectively at 100 place and unit place will be equal to number of numbers where 1 is fixed at 100 place and 5 is fixed at unit place. So for these 2 places, if I talk, it will be either h is greater than u or h is less than u, because there is no repetition. So hence there is the case of h being equal to u is ruled out. So by symmetry only I can say that there will be half number of cases where 100 place digit is greater than unit place. So straight away what I did is that I made all the total number of cases without that restriction and I divided it by 2 to get the required answer. So these are the 2 approaches. Both the approaches are good enough. One should know both of them, right? Now let's move to the next question, and that is question number 8. Now let's come to the question number 8. Now it says that we have to make a 5-digit number without repetition, which can be formed such that now the 100 place digit has to be greater than the 10th place digit and the 10th place digit has to be greater than the unit place digit. So there are 3 conditions here, right? In fact, the 3 digits conditions here. So here we can say that again, if I have this 5 places, then h should be greater than t and t should be greater than u, correct? So if I go by the method of making cases, then definitely it will be a cumbersome, right? Because now we have to manage 3 digits at a time. But that too also can be done because it is not that difficult also. I'm leaving it for the student to do it. I'll be doing it in slightly different ways. So what I can do here is that if there are 5 places, for these 3 places, if I select any 3 out of these 5 digits, right? I repeat this thing. For these 3 places, I have to take 3 digits. I am selecting 3 digits for these 3 places out of these 5 digits available. So how many ways this can be done? Now this is very elementary and I am expecting that all must be knowing. That is 5C3, which is how much? 10. Correct? So what my logic is that if I combine these 3 tasks together to make it a one task, which will have 3 digits, such that 100 place will be greater than 10's place and 10's place will be greater than unit place, and I say that this can be done in 5C3 ways. Now why I am using selection here only? We all know that the numbers can be arranged, the same selection can be arranged to make a different number. But here, since there is a restriction, suppose one of the selection out of these 10 would be, say I have selected, say digit 3, digit 2 and say digit 5. Fine. And now I have to put them here such that this condition is fulfilled. So the only way I can keep it here is that 5, 3 and 2. Although these 3 digits, if I want to arrange, they will have 6 ways of arrangement. But you will find that every time out of these 6 arrangements, you will have only one arrangement which will satisfy this condition, that is the 100 place digit will be greater than 10's place and 10's place greater than unit place, right? Just for more clarification, I am writing all those numbers, so I can write them as 235, 253, 325, 352, 523 and 532. So you can see that none of these 5 arrangements will follow this logic. There is only one arrangement. So that means for every selection, the corresponding arrangement as per this condition is only one, and hence I can say each selection will give me one arrangement. So number of selection itself will give me the number of ways of putting those 3 digits at this particular place, right? So these 3 places together can be done in 5C3 ways, and every time we are left with 2 digits. So for this place we will have 2 options and for this place we'll have 1 option. So overall the total number of ways for doing so is this, which is nothing but 2 into 10 or 20. The same approach can be done for the previous questions also, right? So in the previous question, the 100 place has to be greater than unit place. So therein what we should have been done is that combining these 2 tasks, we would have option 5C2 ways, which is how much? 10 ways. That's what we did if you remember the previous question, right? And for the rest of the places, we would have these options. So again, the number of cases or the number of numbers would have been 60. I hope this illustration is clear enough to understand that how the complexity increases and how do we maneuver our approach to solve those questions, right? So let's move to the last lap of the question.